Exercise 6.4, problem 6 to 10 solution. In a triangle ABC and DEF, angle B equal to angle E, angle C equal to angle F. Then they are asking us to prove which equation is right. So now let's draw a simple diagram. ABC and DEF. What do they say? Actually they say angle B equal to angle E, which means this angle is equal to this angle, right? Then they say angle C. So angle C equal to angle F. Right? So these two triangles, so what happens by AAA criteria? Both the triangles are similar. If the triangles are similar, what does it mean? The ratio of the corresponding sides will be equal. So which means AB by DE will be equal to BC by EF, and that is also equal to AC by DF. This is your main result, right? So now let's write it out, and then from there we'll select which is the right equation, right? So we have this AB by DE equal to BC by EF equal to AC by DF. Now let's select one by one. AB by DE, yes, it is there. So it's equal to CA by EF. No, it is actually AC by DF. CA and AC are the same, but it is not EF, it should be DF. So this is not right. Now let's go to BC, this one, BC by EF. Yes, we have BC by EF, and that's equal to AC by DF, but they have given it as AB by FD is DF, right? But in the place of AC, it is having AB. So this is also not work. So this is AB by DE. Yes, we have AB by DE here, and is equal to BC by EF. Oh, here we have BC by EF. So this is right. Option C is right. But anyway, for completeness, let's check this one also. See, CA by FD. CA by, that is CA is AC and FD is DF. Yes, that is fine. So we have it here. And they say it's equal to AB by EF. So it is AB by EF. No, it should be ED. Right? DE and ED are the same. It cannot be EF. So therefore, this is also not right. So only this option is right. So the right one is option C by AAA criteria, because these two triangles are similar to each other. Okay. So now let's go to sum 7. This is an interesting problem. From the given figure, identify the wrong statement. So triangle ADB is similar to, so basically they have given us this right triangle, right, ABC, and you are drawing a perpendicular from B to D, right, and so it gets you three right triangles, that is triangle ABD, triangle BDC, and also triangle ABC. So you'll have to find the similar triangles. Three triangles are similar to each other. So what I've done is that, see, not only the corresponding angles must be equal. In two similar triangles, the corresponding angles are equal, then the corresponding sides are equal. So you got to be very careful of that. So what I've done is that, let's say this angle C is theta. So what will be angle A? Angle A will be 90 minus theta. For the time being, ignore this perpendicular. You just take only triangle ABC. Angle B is 90 degrees, right? So this is 90. Therefore, if this is theta, this must be 90 minus theta. Now, next step. So let's take angle ABD as theta. So if this is theta, and this is already 90, right? 90 minus 90. So it's all fine. So 90, and you add up, it'll, no, actually we should not take theta. We have to find this, because this is 90 minus theta and this is 90 degrees. That is angle ADB is 90. So now sum of these two is basically 90 minus theta, and this is 90. So you'll get 180 minus theta. But you know the triangle sum has to be 180 degrees. So this has to be plus theta. Therefore, triangle ABD is theta. Similarly, this angle, that is angle DBC, will be 90 minus theta. Can we check it out? This is theta, already we did. This is 90. So sum of these two is 90 plus theta. But altogether we have only 180 degrees, right? So this has to be 90 minus theta. Then only you sum it up, you will get 180. Let's check 90 minus theta plus 90 plus theta. 90 plus 90 will get us 180, and this minus theta and plus theta will cancel off, right? So in any triangle, if you put one is theta in a right triangle, the other one will be 90 minus theta. That is a shortcut. So if I put this is 90 minus theta, then the other angle will be theta, the one other than right angle. Okay, so that is another way of doing it. So, but that's faster, I guess. Now you'll have to draw the corresponding similar triangles. So, similar triangles to ABC. So, the similar triangle to ABC is ADB and BDC. Now, you might be asking how you got this. So, now let's look at it. ABC. A starts from 90 minus theta and then goes to right angle. This is the direction you'll have to keep. So, for ADBC, again A starts from let's now take this triangle ADB. Is it ADB or ABD? That is the question. Now, if you take ADB, it starts from 90 minus theta, then passes to 90 degrees. Therefore, the triangle has to be ADB. But now, let's take ABD. It is not, the angles do not correspond to each other because after 90 minus theta, you are passing on to angle theta. So, it is not corresponding. So, the direction must be ADB. Therefore, triangle ABC is similar to ADB and not similar to ABD. You have to understand that clearly. Now, let's take BDC. Now, you have the option of BDC or BCD. But again, A starts from 90 minus theta, so B will start from 90 minus theta. After 90 minus theta, if you go in this direction, you are crossing the 90 degrees. So it has to be BDC. That is why I am saying it's BDC. But if you go in this direction, if you name them BCD, then what will happen? After 90 minus theta, you are getting onto theta. So it will not be similar. So corresponding angles must be similar. Now, if you see, these three triangles are similar to each other. ABC and ADB. I've taken this triangle and drawn it out for ease of understanding. And this triangle and taken it out. So, a triangle BDC. Now, you check statement by statement. Triangle ADB is similar to triangle ABC? Yes, correct? See, ABC is similar to triangle ADB because they are all corresponding. The angles are equal, corresponding angles are equal because this is 90 minus theta and this is theta, right? Now, next one. So, that is right. So, triangle ABD and triangle ABC, triangle ABD, triangle ABD and triangle ABC. No, they are not. Triangle ABC is similar to triangle ADB. It is not similar to ABD. So, option B is not right. But for completeness, let's finish it. Triangle BDC. Triangle BDC is similar to triangle ABC. Yes. See the direction. ABC and BDC. They are similar. Triangle ADB is similar to BDC. See BDC. So that is also right. So in this case, this option, the direction is getting changed and as a result, we are not having corresponding angles. Therefore, the triangles are not similar. See, triangle ABD, it is in this direction. From 90 minus theta, you go to theta. But whereas triangle ABC is from 90 minus theta, it goes through the right angle. So therefore, these two triangles are not similar to each other. This, I think it's missed out somewhere. It's not clearly explained. I guess this is the important point. So if a perpendicular is drawn from the vertex of a right angle triangle to the hypotenuse, then the triangles on each side of the perpendicular are similar. This is our theorem. That is, whenever we draw a perpendicular, then you get three triangles, right? One triangle ABC, then you get ABD, then you get BDC. All these three triangles. This triangle is similar to this triangle and these two triangles are similar to the bigger triangle. But you got to be careful about the direction. If you are not careful about the direction, it will go wrong. Okay. So, by that statement, we know it is the option B is not true because the direction is not right. The angles are not coming in a corresponding way. Right. Now, let's go to problem 8. If a vertical stick 12 meter long casts a shadow of 8 meters long on the ground and at the same time a tower casts a shadow 40 meters long on the ground, then the height of the tower is. So let's draw two triangles. So this is the vertical stick is there. So this is a ground. So vertical stick 12 meters long casts a shadow 8 meters on the ground. Now there's a tower. Okay, and it casts a shadow of 40 meters. But you know, there is a like these two triangles will be equal, like similar, because this angle equal to this angle, both are 90 degrees. So if we have, you know, let's, the sun is somewhere here, right? And the sun is also sun. So this is angle, this angle will be equal to this angle. Okay, so since these two angles are equal, these angles also will be equal. So by AAA criteria, actually this and this itself is good enough, right? Because it's the same sun and it is the same vertical pole. One is vertical pole, the other one is a vertical building. So the angle of incidence will be the same, right? So this angle will be same. Actually, it is angle of depression in trigonometry, but anyway, this angle of incidence we can just take, or you just take this angle will be equal to this angle, because angle of depression is seeing from there. So this angle will be equal to this angle, right? So since one set of angle and another set of angle, two sets of angles are equal, these two triangles are similar. So as these triangles are similar by AAA criteria, then what will happen? The ratio of the corresponding sides will be equal. So what is the corresponding side? The vertical side. So 12 by DE will be equal to BC by EF. So you substitute the numbers, or 8 by 12, that is BC by 12, the horizontal by vertical will be 40 by DE, right? And let's the DE be X. So now you cross multiply. X will be 40 into 12 divided by 8, right? And this on a cancellation will get you 60 meters. Am I right? 4 will go 2 times and 4 will go 3 times here, right? And 3 will go, sorry, 2 will go 20 times, so 23 is a 60. So this is a simplification, right? So the answer is 60 meters. The height of the building is 60 meters, option D. Now let's go to option problem 9. The sides of two similar triangles are in the ratio of 2:3. Their areas are in the ratio. We know the formula. The ratio of the areas of two triangles is equal to the ratio of the squares of their corresponding sides. Since the ratio of the corresponding sides of the sides similar triangles 2:3, the ratio will be 2 square is to 3 square. So that is 4:9. It's a simple problem. If you know this fact, then it's very simple. The other one is perimeter, right? The ratio of the perimeter of two similar triangles is equal to the ratio of the sides, corresponding sides, right? Problem 10. The triangles ABC, DEF are similar if their areas are 149 centimeter square respectively and BC is 8.2 centimeter, then EF is equal to. So let's draw. So what it means is that, see, they are similar triangles, right? So BC and the area of the triangle ABC divided by triangle of DEF will be equal to the ratio of the corresponding sides. They are given the side BC and they are given EF, right? So BC will be, actually you can find out, see, BC is BC by EF the whole square. This is what we saw right now. Area of the squares of similar triangles is the square of the corresponding side. So BC by EF square will be equal to area of the triangle ABC divided by triangle DEF. So now you substitute these values. BC is 8.2. 8.2 divided by EF will be equal to area of triangle ABC is 100. Area of triangle DEF is 49. Right? So that is 10 square by 7 square. Now you take LCM. Sorry, square root 8.2 by EF will be 10 by 7, or EF will be 7 into 8.2 divided by 10. This on simplification gets us 5.74 centimeter. Am I right? So that is option B. Okay, so you need to remember the ratio of the areas of similar triangles is the square of the ratio of the sides, the ratio of the corresponding sides. Okay, so I hope it's clear. If not, please go through this one more time, it will become clear. Thanks for watching this video.